In this video, we're going to demonstrate OS deployment using the automation built into Open Manage Integration for VMware vCenter, also known as OMIVV. Now, automation and integration are two terms that are both overused and misunderstood. And the reason is every vendor applies them differently. For example, many vendors would describe the plugin that they create for vCenter as integration, but that may still require the administrator to jump between their hardware console and vCenter to accomplish most tasks. With OMIVV, there is no hardware console. 100% of the functionality is initiated from vCenter. Many vendors might describe automation only in terms of the components created by them. For example, many of these vendors might talk about deployment automation in terms of the configuration of the server, ignoring the fact that the operating system still needs to be installed. OMIVV looks at automation from the perspective of the administrator and considers the entire process. So let's do a quick introduction to OMIVV deployment. What you see on this screen is a vCenter instance the administrator will be logging into. On the left-hand side, we have 4 iDRAC consoles representing 4 FC430 13th generation servers from Dell. We'll be using those to watch the installation a little bit later in this video. But the setup of OMIVV is very, very simple. Most importantly, it's also tightly integrated. So for example, it uses automation functions already present within vCenter, like vCenter's host profiles functions. Host profiles is an automation mechanism that ensures consistency of network settings and storage settings for all the servers in the environment. And OMIVV works closely in conjunction with that. Now, installation of OMIVV is simply the deployment of an OVF. So it shows up as a virtual machine in your environment. In this case, we've only got one server in this environment. But we'll take a look now at the Open Manage Integration tab and what it provides. First, it provides a view into all of the Dell and EMC hosts that are installed in the environment. So on the bottom left-hand side, Dell EMC host tab. Click on that and it will show all of the servers that are installed. In this case, we only have the one server. But from this tab, you could actually navigate to look at the health of the system or to be able to access its iDRAC console. Going back to the deployment phases, during the initial setup of OMIVV, it will walk the user through a wizard that asks for the connection profile information. Connection profile information is simply the login IDs that the administrator wants to use for their new environment. Things like the iDRAC console. You should never use the default password. You should change it immediately. This is the area where the administrator would set what they want their iDRAC password to be. Similarly, this area is the area where they would set what they want the ESX host root password to be. So when vCenter needs to access any of these servers, it can do so directly using those passwords. The next phase for the administrator is to set the hardware profile. Now, hardware profile is essentially the BIOS settings of the system. And the way OMIVV accomplishes that is it creates a wizard that will extract the BIOS settings from an existing server that you could be using in production. So set up one server, make it perfect, and then use OMIVV to extract all of the BIOS settings and iDRAC settings from that system. This includes settings like processor settings or memory settings, but also things like system security and how you want the system configured in a production environment. It can be changed if appropriate. But for the most part, many customers will just leave them the same, so they have a consistent hardware and software environment when they're done. Everything including the iDRAC passwords and how it's configured. Next, the administrator would set up a hypervisor profile. We've already set up 3 here, but we're going to be using an ESX 6.0 update 2. This is simple as well. Essentially, a wizard pops up that allows the user to enter the source where he's putting the ISO. You can put it on an NFS share, you can put it onto a Windows file share, and it provides a facility to test to make sure that that image is mountable. We've already set this up, but we'll go through a quick test to make sure that it's accessible. Press the test button, and it finds that the path is there and the file is there, so we can cancel out of this. The final step is to create a deployment template that marries the hardware profile with the hypervisor profile. We've created one here, but we haven't populated it yet. Once it's been populated and saved, it can be retained and used for future deployments as well without making any changes. So we're going to add in the hardware profile that we want to use for this deployment, which is the one we just pointed to a moment ago. Next, he's going to choose the ESX instance he wants to install, ESX 6 Update 2. He's going to save it. Now all the administrator work is done. This is the simple setup, takes almost no time at all, and his next phase would be actually to start a deployment. He would do that from the bare metal server page where he could run the deployment wizard. Now all the servers listed here were manually added using their IDRAC IPs, but they can also be automatically populated by simply doing a configuration setting, requesting that capability when you order your Dell server, and it will come ready to be integrated within a vCenter environment. Now, to understand the benefits of automation, it's important to take a look at what a manual approach looks like. So I've got a video that walks you through what a manual installation looks like. On this screen, you see a Cisco UCS environment, and on the bottom right, we have a stopwatch that'll run through the process to give us a real-time view of how long this takes. We're going to accelerate the video quite a bit to try to save some time. But note, all manual installations are pretty much the same. There's a number of major steps that have to happen. First, the server configuration has to be set. The administrator started that process here, so we've started the timer. Once the BIOS settings have been set, the next phase is the administrator has to mount the ISO. So he has to make the ISO available so that the system can boot. Next, he'll boot the ISO and install the operating system onto the bare metal server. Once the operating system is installed, he would then go to vCenter, add that new host into the vCenter environment, and configure it for use. That includes setting of the network configuration elements as well as the storage configuration elements. Now this particular server is still going through its initial setup, and we're going to go through this initial setup a little slowly. We've accelerated the video about 4 times real time. Later on, we're going to accelerate it to 64 times to get through it a little quickly. But first, we just want to take a look at what the installation of a single server looks like. It is very time intensive, but it's also very error prone. Anytime there's a manual process, it induces the possibility of human error. Human error can be something as simple as a mistyping of a password, typing in the wrong IP address, or potentially even missetting configurations, so using the wrong hardware configuration. And we'll look at how that affects the installation towards the end of the video. In this case, he's mounted the virtual media now, so he's mounted the ISO and he's ready to start the installation process. We're about 6 minutes into the process itself. The server is going through its first boot, and it will boot the new ISO that we just mounted. The other challenge with the manual approach is it's very time consuming. All through this process, the system is going to be asking for information, whether that be what the password should be or just simply press enter to continue. The administrator can't really afford to leave it alone. If he walks away for 5 minutes, he risks slowing down the entire process because the ESX instance will be waiting for him to provide some inputs. So administrators tend to sit down and just plan their time so they can spend a day doing this kind of work. It's very time intensive. And everything you see here has to be replicated 3 more times. So the work that the administrator is doing doesn't end after the first install. It's simply the start as he continues to bring all the new servers into production. With that in mind, it means that for 4 servers, if it takes an hour, then 8 servers is probably going to take 2 hours. So the time starts to continue to add up, the more servers that need to be installed. In this case, we're still going through that boot process. We're 11 minutes into the process, and now it's asking for some inputs from the administrator. Things like what hard drive do you want to install ESX onto? What is the root password you want to use? When it's done, it will ask him for confirmation that he wants to install ESX. Again, the administrator can't afford to leave the console because it's going to ask him for more information a little bit later into the process. We're now 14 minutes into the process, moving on to 15 shortly. ESX is going through its final configuration steps right now, at which point it will reboot and bring up the instance of ESX into production environment. Now, we've set up a DHCP server, so the administrator doesn't have to manually enter an IP address. In some customer environments, they may have to do that, which would slow things down again. So this video again has been accelerated 4 times normal. So we're 16, almost 17 minutes into the process. We don't even have one server up installed yet. But that server is finally starting its final boot. It's been installed, it's ready to go, and the administrator can shortly work to add this into his vCenter instance and begin to use this server in his environment. Server's online, has an IP address. The administrator now has to go into the vCenter environment and add it into his data center. An example of human error, in this case he types a password and it's the wrong password, so he has to retype it. But once he's done that, vCenter will go off and do an inventory of that server, at which point it will bring that server online, ready to be used. As you can see, it's been completed, but it's also been brought up into production mode, so it's not in maintenance mode. That can be a bit of a problem, but that's the standard approach for a manual installation. The administrator has also not set up redundant NICs. He's only got a single NIC set up. He did set up a vMotion network, but he hasn't set up all of the other VM networks that are necessary. He plans to get back to that at a later point in time. The challenge is, though, another administrator could see that device online and think it's available for use and start deploying virtual machines to it. What you see here is we've accelerated the video to 64 times, and this administrator was getting bored, so he's starting to do 2 servers in parallel. We'll try to get through the process a little bit faster. We're 49 minutes into it, and he is still working on his final server. So total time from start of this process to integration of the final server into the environment took 1 hour, 1 minute, and 19 seconds. Might seem reasonable for many customers, but there's huge opportunities for improvement here. Not only improvement in terms of time, and we'll show that in a couple of moments, but also in terms of the process, because throughout this, several errors were created. You may have seen the example at the beginning where he typed in a wrong password. Well, the same happened later when he was setting up ESX. It's not a big deal. It's easy to fix. But on the right-hand side, in his rush to bring these servers online and get started on the next ones, the administrator didn't get around to adding in the NIC redundancy and adding in the VM networks. Since this server is in an online environment, another administrator could be using this, which would be a big mistake because the server is not yet ready for production. It doesn't have the redundancy nor the capabilities necessary for their production environment. On the next page, this would have been missed because the video was moving very quickly. But this administrator actually messed up a little bit as well when they set up the template for the server configuration. One of the steps they missed was the storage configuration for the local storage. So what happened was that the system accepted the defaults, but several of these servers had been used previously. They were set up a little bit differently. The one on the left, for example, is set up using a single drive and a JBOD. The one on the right has been set up using RAID 0. Now, this may not be noticed at first. Nobody would notice that the hard drives are booting in a different mode. But at some point in the future, when a hard drive fails in the JBOD environment and that ESX server has gone down, it'll become apparent to them that there was a misconfiguration. These are little things that customers struggle with every day and can be greatly improved through the use of automation. So with that, let's take a look at what an automated deployment looks like using OMIVV. On this screen, we still have the stopwatch on the bottom. That will be accelerated a little bit. The user is going to go through and choose the deployment templates, and we'll walk through this in a little bit more detail shortly. But on the left-hand side of the screen, we have those 4 iDRAC consoles. And what you'll be able to see is that OMIVV will automate the entire process. At this point, the administrator's done. After little under a minute, his work was done, and he can be off doing other tasks. The servers are going to be automatically deployed, automatically inserted into vCenter, and automatically prepped for use by the host profiles function for automated setup. In this case, all these servers are now deployed. They're ready to go, except that they haven't run through the host profiles function, and we'll walk through that a little bit later in the video. Now, some of the things that might have been missed because it was moving very, very quickly, is that if the administrator does want to see the status of the installation, he can actually just go to the monitoring tab at any point, hover his mouse over the details section, and it will show him where each server is in the boot process. So it will demonstrate to him how far it's come and what steps are necessary moving forward. I mentioned that this can save time. Well, let's take a look at how much administrator time was actually taken to do this. Timer on the bottom right, sync to real time. The user picks the servers he wants to deploy to, chooses the deployment template that he created earlier, determines which disk he wants the system to be installed on, determines the vCenter server, and then assigns the credential profile he wants to use. And if he chooses, he can actually assign a separate credential profile for each server. Now in this case, we're using DHCP, so that automates everything, and he can apply these settings to all the rest of the servers. Finally, it will take him to the scheduling page where he can choose when to have the installation take place. We're going to do it immediately, but he's going to start by giving the job a name so we can track it. He's going to choose which container to put it in this case, the Texas data center. And he's going to associate the host profile that we want to use when we're done, so we can do an effective handoff to vCenter. You can see the entire process took 51 seconds. I mentioned that it's important to have tight integration with vCenter. So one of the elements that this tool does is it pre-populates the host profiles function with all the servers that have been created, so they're ready to be modified. Now notice that all of the servers came up in maintenance mode, so they're not in production yet. Nobody can be deploying virtual machines to them. And it's a good thing because they're all actually misconfigured. At this point, they all have a single NIC. They only have a management network set up. But using the host profiles function, it's been automatically populated, so the remediate function will bring up all those servers automatically. The administrator simply presses the next button, confirms the settings, and then applies them to bring those servers online or to configure those servers for online use. And this entire step took less than 1 minute with 51.77 seconds. Now, having done this work now, the servers are going to go through their host configuration step. Then they're going to go and vCenter will double check to make sure that everything is configured correctly. So we'll give that a minute to complete. And again, all of this was accomplished through automation. No opportunities for errors. Every server has the same hardware configuration. Every server has exactly the same network and storage configuration within ESX. And every server is now ready to go directly into production because they're properly configured. If we just do a double check on that, we can check the server, confirm. We now have redundant NICs. We now have multiple VM networks, and we have vMotion set up. Similarly, host profiles has added in the FCOE software driver, so it's ready to connect through Fiber Channel. And all 4 servers are configured identical to that gold master that we identified at the start of this process and that we took this configuration from. So this concept of copying a gold master server and replicating it in your environment is very, very powerful. It can greatly reduce errors. It can significantly speed up the environment, and it can ensure consistency for your entire ESX environment. At this point, the user can simply bring all these servers out of maintenance mode and put them into production because they're configured identically and ready for work. So the benefits then, first is time. The OMIVV automated deployment took a total time of 26 minutes 43 seconds. Of that, though, less than 1 minute and 43 seconds was required of the administrator. For the rest of that period, the administrator could be off doing other chores or balancing configuration work or resetting clusters or moving virtual machines around. It took him 51 seconds to deploy the OS, and it took him another 51 seconds to apply the host profiles. Compare that now with the manual deployment. Doing the same 4 servers took a little over an hour, 1 hour, 1 minute, and 19 seconds. And the administrator time was the same because the administrator had to be available for that whole hour to be able to hit the enter button, to enter the passwords as appropriate, and to enter the information to bring that host into the ESX environment. So very, very time consuming, but using automation greatly reduced the impact of that. So in summary, OMIVV delivered 130% faster deployment time, 26 minutes versus 1.01 hours. 97% less administrator time, 1.43 minutes versus 1 hour, 1 minute, and 19 seconds. 0 configuration errors for OMIVV versus 1 hardware configuration error with that disk configuration we showed you using the manual process versus several requirements to retype passwords, simple human error issue, and also versus the networking configuration elements that needed to be added in later, but which could have accidentally caused the system to go into production when the host configuration did not automatically go into maintenance mode. So at some later point, this administrator is still going to have to go in, set those NICs up for redundant connections, and add in those network segments. Hope this has been helpful. Thank you.